Job that I'm doing today is working on this 1622 B series race engine. I've bought it already. I've got to skim the block, hone the block, fit new cam bearings into it. It's been through the acid. I need to just take the other two oil gallery bungs out and clean through there. I've then got to mount it on the mill and put valve cutouts in the block to clear the valve with a high lift cam. So like I said before, it's just been through the acid, so now it's block prep for me and fitting the cam bearings. So I'll time lapse the cam bearings going in. First of all, I'll just give you a brief description of how I do the cam bearings, because all of them are different sizes and they've got oil holes in them, and some of the oil holes are offset, so it is super important that these are fitted the correct way. Even this hole, or this oval hole here, is offset to one side. It's quite easy to do really. I just use a paint pen and the cam bearing installation kit, which is in here. I make sure that the cam bearing bore, I knock the old cam bearings out before it goes through the acid, so it cleans any of the oil out from behind here and in here. So this is one of the cam bearing installation kits that I've got. So basically it's a cone that centralises on one of the other cam bearings. So if I'm fitting the centre or this end cam bearing, the cone sits in there to centralise it off the front. Then this is the shaft with the hammer end on it, so I can hit that to drive the new cam bearing in. Then these are expandable collets with a rubber end on them, so they don't actually damage the cam bearing. So basically the cam bearing would sit over there. You use this one on the centre and one of the ends, and then the smaller one on the other end. And then this is the adjusting collet. It's got a taper here, so when we tighten it up, it expands that, or expands these to grip onto the bearing. So it's a really simple but effective way of fitting cam bearings. So the first thing I do is to make sure everything's clean, as I said before. So I'm starting off with this rear cam bearing. So the first thing I do is, just with a paint pen, I'll just put a little dot on the inside so I know exactly where the top oil hole feed is, like that. And then on the bearing, I'll match that hole up so that sits that way. So then I just put a little mark along there, so I can see then where my top oil hole feed is, lining up with the block. The next important thing to do is just to make sure that these collars are clean, or the rubber part of these collars are clean. The reason you change a cam bearing is excessive wear, scuffing, corrosion and things like that. So the last thing I want to do is install a brand new cam bearing, and where this rubber part has got some swarf from other jobs or dirt on it from other jobs, it then digs into the lead of the bearing and destroys the brand new bearing. So quick clean, and then that goes on there like that. So then basically when this part is tightened up on there, this taper part here expands this here. The first thing we have to do is install the bar into the block. And then fit that when it's in there, screw it up. And then fit the first bearing. So that goes that way. the lip of the bearing sits against the lip of the driver, so that's what actually drives it in. So it does need to be quite a snug fit onto the driver, and then it's just a case of lining up my paint marks, and then the rear, if this is picking it up, this rear cone sits into the block, and then with a lump hammer, so it's got some weight behind it, I'll use a snap-on lump hammer, keeping an eye on the cam bearing. Just drive it home. And then just as it starts to go all the way in, just back off the tool slightly, and then inspect that the oil holes line up with the drilling in the block. So this one still needs to be installed by, I'd say, about 1 mil. So then once again, carefully just fit the installer. Another couple of taps, check again. It's better to keep tapping it in, checking, tapping it in, checking, than it is just to drive it home. On engines that I do regular, A series, B series, Pintos, Crossflows, I've got scrap cams that I always keep for that purpose. So this is an MGB cam which is scrap, but the actual main journals for it are in really good condition. So the next thing I do is very carefully I oil the journals and then ease the cam in, and there we go. I mean, that spins lovely, that. To be quite honest, they're not always that good, but yeah, that's gone in straight away perfect. So that's that operation done. The next thing on this block is after I've got the cam out, I'll just really carefully take the cam out, because it's quite easy to mark the lead on the bearings. I'll put that back on the shelf. Next thing I'll do is just hone out the cam follower bores. So the cam followers run in here. So what I'm going to do is, just to get any slight bits of rust out and bits of debris, is I'll just run the hone through there, or the brush. And then I'll drill the rest of the oil gallery bungs out, take the main caps out, finish prepping the block and everything. So I'll do all this on time lapse. So one problem with the B series engine is the front and rear main cap they're almost a press fit into the block. So this thread in top of these is the same as the studs. So I've got an old stud which is converted to go on this slide hammer. This is an injector slide hammer, what I've just made work. So screw it in. And then just slide hammer it off. I'm replacing these main studs, these for ARP stud and nuts. So I'm going to remove those as well on this engine. And then the last one, which is the rear one. There we are. So the next thing I'm going to do is take these studs out, clean up all in here. Like I said, I'm going to clean the cam follower holes up next, so I'll record that next. So the next thing for me to do is to remove these oil gallery bungs. These are the two main oil galleries. One runs down here, one runs down here. Then they drill through here and they cap them with these old bronze bungs, and there's some down here too. But what I want to do is I want to clean out the main oil galleries, which are these, and then I can rod the rest of them and send acid through them to make sure that they're clear. So what I do to make this job easy, because sometimes these can be in quite hard, is I drill a hole down the centre of two of them. Ooh. Like that. Then I've got just some normal threaded bar, and as you can see, that's caked in oil, and that's from all the oil that gets trapped in these engines. I only use this on A series and B series, and that was a brand new bit of threaded bar. But what I do is I mushroom over this end, so basically we can send that one through. Oh, I've drilled it to the exactly the right size. So we get that one all the way through. Need to get an hammer. And then because the back one's not drilled, that knocks out. And if you look, that's the oil gallery bung. That's how much dirty old oil gets trapped in these engines. And you know, some people, even some engine reconditioners, they don't remove these bungs. I mean, once I've got this bit out of here, you'll probably see also. I mean, look at that. That is just old, dirty oil. That even my acid can't remove that, because I can smell acid on it. So that's that one out. And with this being a race engine, or even just a reconditioned engine, once the new oil gets warm and starts running through these oil galleries, it will automatically break up what's left in here, and this stuff wouldn't do the engine much good at all. So it just goes to show how important it is to get it clean. So like I said before, I drill the hole one size, and I can flip the block over, and then now I've drilled, or now I've hit these ones out, I then stick this one in, which has got the mushroomed end on, so that end is then bigger than the hole that I've bored into it. And then that's out like that. And then what I'll do is I'll just quickly show you this, because where I hit the other part down, it took a load of the dirt and oil and debris and years of running, and this is just what's on the end. So that's why these engines, they take quite a while to clean, to get all the crud out of them. I mean, in fact, you can't even see the hole that I drilled in the other end. Solid. And there's the other half with the hole that I drilled in. It's just dragging so much dirt through. Look at that. I expect there's a few people out there that have got other ways of getting them bungs out. That's just my way. I've done it since I worked at a company called Ocelli. You can use slide hammers with tapered threads on there, but that's just the way I do it. What I'm doing now is just trying to rod all the dirt out of the oil gallery bung. And the one thing to remember about this is all this old oil would get caught in the turns of the oil gallery bungs, so it is really important to clean it all through. So I've brushed all the oil galleries out. I can now see through the oil ways perfectly clear, but I'm going to put it through the cleaner again, the big cleaner, well, loads of times, and then put high pressure cleaning through these oil galleries. I'll block one end off and then just get it where all the oil ways are completely unblocked, but so much dirt has come out of them so far, I think it's been pretty successful anyway. Looking at everything else on it, that's the cam followers all cleaned out. So what I'm going to do now is check that none of these waterways are blocked, so all the water can flow through where it needs to. I'm going to clean the holes where the core plugs go, so I get a good seal when I fit them. Then I need to clean out the head stud threads, because they would have had years of grime built up in them, so I'll run a tap down them. Then I need to bolt a head on loosely and mark where I need to machine the block for the valve cutouts. Skim the block, hone it, once I've machined the head face, obviously. Today, one of the problems when you do an eye-lift cam, big valve on most B series engines, but especially the smaller bore stuff, the 1622 that I'm doing, as soon as you put a high lift cam in it, well, this is a race cam, so this has probably got about 1.5 mil more lift than a fast road cam. The extra size of the valve and the extra lift means that the exhaust valve wants to hit the block, so unless you modify the block, you can't turn the engine over. It gets so far and then the exhaust valve hits the block. So I've blued the block up, I've marked the gasket where the gasket sits, I've cleaned up some of the exhaust valves and fitted them. This is going slightly bigger than standard. This is actually a really rare head. This is called a HRG head, so it's a crossflow style head that they used back in the 60s and 70s for racing, so this is a really good cylinder head. Standard valves in that, let me grab one and show you. So a standard exhaust valve in a HRG cylinder head is 32.5 mil. Well, I'm going to run a standard 1800 MGB valve, which is 34 mil. So that, and the exhaust also, sorry, the inlet also, the inlet valve standard is 38mm, where the inlet I'm running is 40mm, I think. Let me just grab one. Yeah, the inlet valve that I'm running is 40mm. So I've mounted the block on the milling machine. I've levelled the block up, found my centres throughout the lot. I've worked out how far down the exhaust valve sits in the cylinder head, and I've worked out what my maximum lift is. So I've set my milling machine to give me a clearance, plus also the gasket will be the clearance as well. So I'm going to have plenty of clearance here. The one problem that I do see me having is with the slightly bigger inlet valve. The inlet valve on this side is quite badly shrouded on the bore, but there's nothing I can take out of that because that follows the gasket, where the 1622 has a smaller bore than the 1800. That's just something that we're going to have to try and live with, and I'll put a slight chamfer on it and just try and get it as best as I can. But yeah, that's the first job, is to valve pocket the block for the exhaust valve. Or the first job today, I should say. Once I've done that, I'm going to skim the block, hone it to size, and then that can stay in the cleaner for about 2 hours while I'll get on with the VXR engine. Well, that's the valve cutouts done for the exhaust in the block. The next thing I need to do is just to plop the head back on with the valve in loose, just to make sure that they miss. So I've got a valve in my fingers, put 2 studs in, which will okay. So I'll just tip it up and have a look too. I'm going to put a couple more studs in. I'm going to put all the exhaust valves in and then check it again. So I've got a sneaky feeling I might need to just mount that back up and take a little bit more out of it. The more studs that I can get in, the better the chance of me getting it lined up more accurately. I'm going to drop the gasket on it as well. So one video that I started to record last week, or Saturday, I can't really remember when. I think I did it on my phone as well, so I don't know what the quality is like that, but that is these conrods. These are 1622 Robson Engineering conrods, which are, well, they're lovely. Unfortunately, I think they've been made at the top for a standard pin, where this is running a special made JE piston. So this diameter here was too small for these conrods. So I've taken 1.8mm off this diameter here. I've took 0.9 off one side, 0.9 off the other, to give me some clearance in there. So now that fits. So I machined them on my Delta surface grinder, so it's a magnetic table. You can see the swarf still on it. I've got to wash the machine down, but all I did was line all the rods up like that on the magnetic table, took a measurement, machined it down, cleaned the machine, all the magnet off, spun them over and took the same measurement again. So now the job I've got to do is to just dummy build the engine with one piston, one rod, no rings, just to make sure all this fits into the engine and I've got my other clearances right. So the next job is to get the gudgeon pin and fit that. So another problem that I've ran straight into is the gudgeon pin is a really tight fit into this conrod. So I'm going to need to just hone a little bit out the small end of the conrod. Why that is, I don't know. To be fair, it's a bit frustrating really. It's just more work to do when they should have been done right. But as part of engine building, it's better to check, make sure all the clearances are perfect than to try and do it right. And I suppose it's better to be too tight than too loose. So I'll just set the Delapina hone up, which is this one here. I'll just set that up so I can machine a bit out the small end, so I'll time lapse that being done. But that's it, that's all 4 conrods now honed out, and the gudgeon pin fit on all 4 of them is absolutely perfect. So I'm going to wash these now in the cleaner, just get rid of the berth on the grinder, and then dummy build it and see if there's any more modifications that's needed to the block. But that's the gudgeon pin and the small end all taken care of. So that's the the conrod all machined now. I've dummy built it once, turned it over, and it wasn't tight one side, it was still turned over, but the top of the conrod was just marking the inside of the piston. So I've taken it apart again and I've machined another 0.4 of a mil off one side of the piston. So that's all good. I'm going to do each cylinder one by one, just so I can mark everything one by one. But now that's fine and it turns fine. So the next thing for me to do, just to get the one cylinder in and torqued up and turn over to make sure, is to gap the rings. Now on one of the previous vlogs I went through gapping rings, but I'll do it again just in case we've missed anything. So with every set of rings it comes with a formula of the bore size times a factor to get the ring gap right. So that's the first thing that I need to sort. So I've already gapped the oil control ring, or checked the gap, they was fine. So I've put the oil control ring on the piston so I can square up the second ring. And the second ring gap is a little bit bigger than what I'd like to run, but I think it'll be okay. So that can be installed. Once again, there's a little dot, and the little dot points uphill, so we know which way they get installed, and then just fit them to the piston. Just careful not to scratch the land of the piston. There we are. And then the next ring is the top ring. So once again, I'm doing it per cylinder, so I'm building the front cylinder up first to make all my calculations off. So that's the first one to go in. Once again, using the piston to square the ring up in the bore. I want to run a piston ring gap on the top ring of about 16 thou, but straight away I could see that the ring overlaps. So I'm going to put a tiny little mark on it so I can see how much has got to come off it to get it roughly to the right size. So I've now gapped the ring. I've set the top gap to 16 thou. So the next thing to do is fit it to the piston and then fit the piston into the bore and then measure up for the rest of it. So I'm currently working the compression ratio of the 1622 engine out. So what I've done is I've calculated the distance between the top of the piston and the top of the top ring. And then I've also measured what is in the top of the piston. So this piston sits 20 thou in the hole. And then I've calculated, I've had to put exhaust cutouts in it, which I showed on a video. So I've calculated what's in the exhaust cutout and what's in the 20 thou down to give me a CC. So I've cut the seats on this cylinder head. I've made the seats bigger, I've put larger valves in it, and I've just worked out the CCs in the cylinder head. So if I just move this over to the workbench, I'll tell you the increase in valve size. One sec. So I've worked the compression out, and with what's in the cylinder head, the gasket and the bottom end, with the bore and the stroke that this is running, the compression works out to be 10.26 to 1. The CC of the engine has gone from a 1622 to a 1664 CC because of the rebore. I'm going to take 10 thou off the cylinder head, so that will hopefully make my compression about 10.4 to 1, which is what I want to run to start off with. So where I've opened up the seat in here, I'm going to just blend this edge away in the gas flowing room. So I'll do that before I skim it, just in case I catch the head face, which I shouldn't do unless I've sneezed or something. But I've ground all the valves in, so I've also just got a vac test them, but they've all ground in perfectly. So I'll vlog that tomorrow. It's now nearly 7 o'clock, so I'm washing up to go home. What I always do on all MGs is modify the oil pump, and the reason being is even the good quality old ones was restricted in how it flows, and the new ones that you can buy are just as bad. So if I just get this apart, I can show you. So the oil strainer goes on here, and then it sucks oil up through here, up to here, and then it runs through here and then feeds the bottom of the pump through the hole down there. So basically all this is what controls the oil flow. So what I do is open this up so there's no burrs or anything in there, and then match it to this hole here, and then break through down here to radius this so it fills the pump better. But then also I grind across here slightly so it feeds the pump from the top as well, or the bottom if it's that way up. So that's the next thing that I'm going to do. So that's the pump modified with the small carbide burr. So what I'm going to do now is just polish up the main oil passageways. Well, that's it. I've got a nice straight shot down there now. That's all the burrs and everything moved out of that, and the flat, there's like a flat step in there normally, that's that all gone. I've opened up that part there to flow to the top of the port, gears, sorry. I've broke the edge in there and got rid of the bad casting mark, which you can't actually see, but it is done. And then I've ported down there just to match it up to the top part of that. So that all needs just a good wash now. So I'll put that in the cleaner for half an hour while I put another piston and rod in. Well, that's the last Conrod machine for the 1622 MG engine. The other three are in, all torqued up, so all I've got to do now is fit the piston to the Conrod and gap these rings for this cylinder. So going off the other three cylinders, I would guess that the oil control, which is this one, the two oil control rails, and the center or the middle ring are fine. But do you know what? Take nothing for granted. Check every single cylinder in the cylinder that it's going to. Well, check every ring for every set in the cylinder that it's going to. Don't take it for granted that they're packaged right, because sometimes a little mistake can happen in packaging or anything really. So it's always important to check everything. So the only one that I know will need machining is this top ring here, and it needs about 40 thou machining off it. Now, the one thing that's really important when machining rings is when you've got them to the right gap is to deburr them very carefully, especially on this front face. You need to deburr it so it doesn't scratch the bore. But if I was to put a file across that and put like a 10 thou chamfer on it, what's going to happen is that gap, the sealing gap of the ring, is going to go from being roughly 16 thou to having a 16 thou gap there, but with a chamfer on it. So the gap really is a lot bigger. So I use my total seal deburrer to do the sides, but I always do the front face and the back face. I do that by hand with some emery and just basically tickle just the end of it to get it off. So yeah, so the only ring that I need to do is this one. So I'll machine that and I'll pop back. So I've been and gapped the piston ring. Hopefully this is the right size now. So it's just a case of running a feeler gauge nice and square down the ring, just till you can feel it bite on the feeler gauge, which is exactly there. So 16 thou, and I could probably just about force the 17 in, which I can, but 16 feels really nice in there. It's important to keep the feeler gauge nice and square, and that's it. So I've broke the edge, I've deburred the top, the bottom, the back, and then just broke the edge on the front there. So that's all ready to fit. Just give it a quick check over. There is a direction that these rings fit. It's normally denoted by a mark, or it says top. This one's got a little centre dot on it, so you can't actually get it wrong. And then it's a case of just fitting the piston ring to the piston. You can buy tools from Snap-on for doing this, which I recommend using if you're a hobbyist having a go at building an engine for the first time. I would buy the tool because they are quite delicate rings. You can easily break them, and you don't want to do that. It's also important to be really careful when you move the ring over the piston that you don't scratch this top part. So that's it. I've gapped the piston rings. I've spread them out so they're not all lined up. So the next thing to do is to put some lubrication on the bore. Now, I don't use oil because you just want everything to bed in properly, but Total Seal sell this proper assembly lube for rings. So this is really good stuff. It breaks down very quick. It's available to buy from Total Seal. If you're in the UK, we will be stocking this in the new shop once that's all done. So all I do with that is just put a little bit on my finger and then just wipe it around the top of the bore like that. Then it's just a case of then installing the piston to the rod, For that I use the Cleveite, and I put it in the small end of the Conrod. I'm just get a bit more, and then in the gudgeon pin bore of the piston all the way round. It just helps with initial startup, which is the most important part, or the most highly loaded part of the engine. And then I make sure that it all floats really nice. Like that. So now I've machined the small end. That there is perfect. There's no play in it side to side. And then it's a case of fitting the wire clip. So just fit that like that. I put my finger on the end and then just roll it in, making sure it doesn't scratch the piston. There we are, like that. And then I just wipe off any of the excess build lube, and then check that everything is really nice and clean all over it. And then I get one of the bearings, clean the bearing, make sure that's got no bits of dust on it, no dirt. I'll keep them in the packaging until it's getting built also. And then just very carefully fit the bearing into the conrod. Once again, making sure there's no burrs, nothing to cause any issues. And then I put some bearing guard on it, which I just make sure I've got it completely covered. And then I haven't actually got one of the tapered ARP ring compressors for this size bore, so it's back to using the old C-clamp style. So for that, I just make sure that the gap in the C-clamp is nowhere near any of the gaps of the ring, and then carefully just hold it down. This one's made by Snap-on Tools. And then this is a Snap-on Tools piston installation hammer, which is available from your local franchisee. And then once it gets close to the rings, I can see the rings down this gap here. Just give it a good tap, like that. And the rest of it I install by hand. So what I'm going to do now is I'm going to tip the engine upside down, finish torquing it up. So I'm going to go and wash my hands again just to make sure they're double clean. So all the pistons are in and torqued up. The main caps are now torqued up. ARP big end bolts, ARP main cap bolts. So now I'm going to just put a little bit of Loctite on these oil gallery bungs for the rear of the engine and fit them, and the same on the front. These are the ones that was a solid bronze insert that I removed the other day to get the oil waste clean, which I recorded, so you saw that. So these are the replacement. They're no longer solid inserts, they're little like cup style core plugs. So a little bit Loctite all the way around just to lock them in once they've been hit home. Just got to make sure that they sit below that rear face as well. That's it, that's all done. So now I'm going to go and get the rear plate and the front plate of the engine and bolt that in. I'm going to get the oil pump now and also bolt that in. Then the next thing to do is make a baffle for the sump. The HRG cylinder head has got the bigger valves in it now. The seats are cut. I've skimmed it to get the compression where I want it. So the next thing I'm doing is measuring the installed height for the Kent cams valve springs that I've got for it. So to do this, I've put a valve in. I've got a spring retainer the spring seat in there, and I'm just going to measure from there to there. And then with the verniers, give it a quick measure to see what my installed height is on, well, that's an inlet valve first. And then the next thing I want to do is just put in an exhaust valve and do the same. I'm going to keep them in order of where they've been ground into. Just measure from the top to the bottom. And what that's showing with these retainers, these are Cam's retainers, and that spring seat, is I need to put a 2mm shim underneath here to get the platform right. So what I'm just going to quickly try is the original retainers. Just make sure they sit on the springs okay first, which they do. Oh, there we go, that's better. So the installed height of the valve spring, these are a VS27, and then it tells you in the Kent book, VS27, it's a double spring and the installed height should be 40mm. With the Kent retainers, it comes in at 42mm, but with the standard retainers, it comes in at 40mm. So I'll just double check that on this inlet valve as well. Yeah, and it's bang on 40mm. And then you can see the difference with the standard retainer on it. You can actually see this circlip groove, but with the modified retainer on it, the retainer sits level with the top of the valve. But getting the installed height of the valve spring is important because that gives you the right seat pressure. So all I'm going to do with them is just wash them off. The valves have been in a cleaner, and then the head's ready for assembly with the new spring. So I've got all the installed height right for the valve spring, so what I'm going to do now is build lube around the collet groove and down the stem of the valve, just to make sure that the valve guide is well lubricated. Just make sure it slides up and down really well. And then using the valve spring compressor, just compress the valve spring, put the two collets in, and release that like that. And then it's just a case of next valve, and keep repeating the process until the head's built. So the next thing for me to do, I've got the cylinder head on, I've nipped down a couple of the bolts, not tight, just to put a bit of pressure on them. These are the cam followers, but what I'm going to do is just drill a small hole in the side, just so the oil can drain out of them, just help with the valve train weight. So just put a little hole in there and it will just help the oil keep bleeding back through. So while I've been waiting for the GoPro to charge up, I've fitted the cylinder head, I've torqued the ARP head studs up. One problem that I did have, which you might notice if you're eagle-eyed, is this stud's different. This stud here originally, it had pulled and stretched it so it wouldn't reach the correct torque. So what I had to do is make a stud for it, because it's 5/16 UNF here, but it's 3/8 UNC down here. So I've had to make a stud work for that, but that now torques up fine. So that's good. So one job that I've done is I've moved the crankshaft away from TDC so I can put a socket on the end of the cam, turn the cam and set the tappets. So I check the tappets two ways. The first one being is on the rock. So basically what I'm looking for is the two valves on the cylinder to be on the rock like that. So one's going up, one's going down, if I could just move it like that. And then basically I can then set the opposite cylinder. So with these feeler gauges, you can buy these where it's a blade in a handle, so they're quite handy for these engines. They're all marked with the metric in the imperial size, so 22 thou. So all I then do is just make sure it's got a really good feel to it, like that, which is perfect. So once I've done that one, I can then move on to look for the next one rocking. So once again, just turn it over nice and easy, and then watch this one here, just comes onto the rock, and then I can check the cylinder next to it. I've already gone through and roughed these out, so I'm just giving you an example of setting them on the rock. The other way to check them is called the rule of 9. So basically, if I start with this one, if I get it where it's on maximum lift like that, use the rule of 9. So this is valve number 1. So then we check valve number 8. Add them together and it's 9. So that's fine. And then you can move on to the next one. It's normally the third one along. This one here. So that's now on full lift. So that's valve number 3. So you check valve number 6, which is that one. So what I do is I always run through and check them both together. Once again, turn it over for the next one. So that's valve number 5. So I'm going to check valve number 4. Valve number 2, so I check valve number 7. Like that. And to adjust them, it's really simple. On these style rockers, Ford Crossflows are the same, Triumphs are the same, but you've got 1/2 inch spanner, put it over the end of a good thick bladed screwdriver, and all that we do to adjust is undo that and then tighten or loosen it, whether we want to close the gap or widen the gap. But I've gone through them, so they're all fine. Because this is a race cam, the other thing that I want to check is that the valve springs are not going coil bound with the lift. So once again, I have already checked it, but I'll show you that. So it's just a case of getting one of them on full lift. So we'll start with these two. Like that. And what you're looking for is roughly about 40 thou in between the links, which we've got loads more than that, so we know we're good on that. And the other thing that I want to check is where I've machined the block to take the exhaust valve. I want to make sure that my calculations was fine and that the exhaust valve is nowhere near the block. So using my snap-on bore scope, I can just put it down the plug hole, put it on side view, and then what we should see if we turn it round, sometimes it takes a second to get your coordinates right. So there's the valve on full lift, there's the valve seat, so we need to go round a bit, and there's the pocket. So we're well away from that, it's going into the pocket. If we go below the valve, there we are. So there you can see the pocket that I've machined and how much gap we've got. You can see the crosshatch finish of the hone, but we've got plenty of gap there for a bit of valve bounce if it ever gets it, which hopefully it won't. And heat expansion and all that. So yeah, there's some of the tests, which are all good tests. So the next thing for me to do is to set the cam time in. So what I'm going to do is, I haven't got the chain or anything on at the moment, so I'm going to get the inlet valve where it's got some lift at TDC, then put the chain on, then put the protractor on, and then check my timing at lift at TDC and at degrees. So I'll do that. But what I might do first actually is put the oil pump on. So that's the 1622 or 1664 as it is now, all finished. The timing's done, the tappets are done, the sump's on, the water pump's on. So this is the HRG cylinder head, all ported in-house. The timing's set to 103 degrees. And then the build sheet for it is up here. So we've got all the data recorded. So I just want to end by saying thank you to everyone that has subscribed and enjoyed the videos so far, liked and left comments. If you've enjoyed this video, then in the comments section below, just leave the word valve, please.